Okay, so now that we have this histogram showing us the lengths of these fingers, we're going to split our data or separate our data out based on the other variable in our data set, the which finger variable. Now, a little tip about JASP. Here we can only see what's the output, which is what we get once we do some sort of analysis in our software. If you hover over these little arrows, you can click this one, and this opens up the input menu where you can make changes. So for example, if we clicked this, then JASP will automatically update your output based on what you are selecting in your input menu. So I'm going to take that back off. And I can close that menu. I can, even with this menu open, also open so I can see my data. And you can actually sort of, if you hover a little bit, you'll see where this turns into a double arrow. So you can move things around a little bit, right? So I can actually see my data here and my input menu, right? And I can move it over on this side too. Wait, I think I can. It's a little tricky to get just right. There we go. So I can see my data. I can see my input menu, and I can see my output. So here, I'm going to go ahead and close. So this was my first histogram. As I said, now we're going to separate the data by the variable which finger. So we're going to again go into descriptives. This pops up a menu. You'll notice in my output, it saved my first one, and now it's opened another one. If I wanted to just update the one that I had here, I would click there and it opens up that input menu. But I want to go ahead and leave this one as is. Right? I don't want to mess with that output. I want to go to the one below it. So let me scroll back down, and this one opens this input menu. So again, I want to look at the histogram of finger lengths. And to get the histogram, since histogram is a sort of graph or visualization, or what we often call a plot, I'm going to expand the plot menu, and I want to see that distribution plot. It's just a fancy name for histogram. So it shows me what does the distribution of finger lengths look like for this particular class that we're looking at. Now, if I want to split this into different fingers, we're going to take this which finger variable and we're going to move it to the split area of our menu. And then so we can see better what it looks like, let me go ahead and close that. So now this was our first output. As I said, JASP will keep it there for you. Now we can see descriptive statistics, the data, just by moving that one thing, which variable, into split. Now we can see it's split all of our data into, here are just the middle fingers, here are the pinky finger lengths, pointer fingers, ring fingers, and thumb fingers. And then as we scroll down, we can see, well, here, this is showing us just the middle finger lengths, right? So we can see that the middle finger lengths range from about 60 millimeters all the way up to this really long one, which was in the 90s, right? 90. How does that compare to, for example, pinky fingers? So the pinky fingers we can see can be much shorter. Some of them are as short as 45 millimeters, whereas for middle fingers, none of them were that short. The shortest one was 60. So here we can see the lengths are already shorter based on our x-axis. Whoops, sorry about that. It's very touchy. So we can see pinky fingers 45 to 65. Middle fingers, 60 to 95. So what can we sort of, conclusions can we draw from this information? So what I'm taking away is that the pinky fingers tend to be a lot shorter. They have lower lengths than middle fingers. And hopefully that's not a big surprise to you if you look at your hand. However, we can see here 60 to 65 and here 60 to 65. So there is some overlap. Some of the longest pinkies in this class data set are about as long as some of the shortest middle fingers. Okay, so this is some practice reading these. Now, histograms, as you hopefully know, or are finding out from the videos, the lecture videos, histograms always plot counts or frequencies. That's why it's called a frequency distribution. We're just looking at how are the different finger lengths distributed? How many short ones, long ones, in between ones? So here we can see in this particular class that it looks like there were 3, right? If I see 1, 2, I want to see how tall this bar is. I'm going to trace it across to the y-axis and see it's hitting between the 2 and the 4. What comes between 2 and 4? 3. So that's probably not a question you thought you'd be asked in your college level statistics class. What numbers between 2 and 4? But so we can see that there were 3 fingers in this class, 3 middle fingers in this class that were between 60 and 65 millimeters long. There were another 3 fingers in this class, 3 middle fingers, that were between 65 and 70 millimeters long. Here we see this jump, so if we want to see how tall is this bar, how many does this represent, I'm going to come across here, so looks like 9. There were 9 middle fingers between 70 and 75 millimeters. There were also 9 middle fingers between 75 and 80 middle fingers. There were 2 between 80 and 85. And then this gap right here, what does that tell us? It tells us that there were 0, there were no middle fingers in this class between 85 and 90. But there was 1 that was between 90 and 95. Okay, so this is how you would read or interpret this histogram. Counts is telling you, literally counting how many, and it's saying how many are in this bucket, how many are in this bucket, and so on. So the tall bars represent those ranges of numbers, those buckets of numbers where we have a lot. The short bars, or even missing bars, show where there are few or none belonging to those sort of numerical range categories. Okay. So there's our middle finger. Here's our pinky finger, right? We got a lot of short pinkies, very few long pinkies. That's how I would interpret that. Here we can see pointer finger, which is an interesting shape. So we've got a lot of pointer fingers between 55 and 70. And then these are people with really long pointer fingers. This one looks very beautiful. Actually, it is pretty normally distributed. You see how it's low on either end and high in the middle? So what we're going to be calling like a roughly normal shape to our distribution. So we can see our ring fingers generally range from 55 to 80. Most of them are in the middle. And finally, our thumbs. And how do thumbs compare? We're looking similarly to pinkies, 40 to 65. How is pinkies? Pinkies were 45 to 65. So this means we even have a few shorter thumbs than we do pinkies in the class. So when we separate it out by which digit, it gives us a little more information than we see here. Here we're seeing all the thumbs, all the pointers, all the middles, all the rings, and all the pinkies all graphed together. This little bump right here, I know from down below that this is a middle finger, right? Because the middle finger is the only one that went up that high. The rest of them didn't go that high. So this guy right here, this is definitely a middle finger. on the low end, I'm guessing these are probably thumbs and pinkies, but there is some overlap, right? Oh, sorry, I'm looking at the wrong one. Down here, I imagine some of these are thumbs and pinkies, right? The short ones. But we can't really see which ones are, where are the thumbs and pinkies, where are the middle fingers, where are the pointers. It all kind of gets lost in this graph because they're all being put together. If we want to try to explain some of this variation, like why do we have some really short fingers? Why do we have some really long fingers? Why do we see different numbers for different finger lengths? And we can see by splitting it up that a lot of that has to do with, well, which finger are we talking about? If we're talking middle fingers, pointers, and ring fingers, those are going to tend to be the longer fingers. If we're talking thumbs and pinkies, those tend to be the shorter fingers. So we're going to see more thumbs and pinkies on this end, more rings, pointers, and middles on this end. But again, there is going to be some overlap here that we can't really make out without splitting the data further to try to explain why we see this variation, why we see all these differences here.